right. Good morning. Okay. So, a systems of equations, okay, is two or more equations that have the same variables. Okay, whatever I write down, you guys should be writing down, okay? So, graphically, when you have a point, okay, when you graph your two systems of equations, what happens? What do those two lines do? They cross, right? They intersect, okay? The two lines intersect. So algebraically, the point x and y makes both equations true, okay? They make the equations true. So let's talk about the different types of solutions you can have, okay? You can have graphs with systems that have intersecting lines. What do you think intersecting lines look like? What do they look like? Right, they cross. They look like an X, right? So you're going to draw your intersecting lines. They should cross somewhere. They should intersect. Okay? So, what do you think their solution should look like? What should their solution? If they have one solution, what should it look like? It has to have an X, but it also has to have what? Parentheses. It has an X, but it should also have a Y. Okay? It's going to have an X and a Y. It's going to be 1 point. Okay? So what about parallel lines? What do parallel lines look like? They don't cross, right? They're what? They're equal. They have the same slope. So do they ever touch? No. Parallel lines never touch. Okay? So, will they ever have a solution like this one? No, right? They will have no solution. That's a symbol for no solution. Okay? So, what about the same line? What happens if you have the same line? What do you think that's going to look like if you plot it in Desmos? Right, it's just going to have two different colored lines on top of each other, right? So they're going to have an infinite solution, and today I want you guys to write infinite solutions like that. Okay? So, there are 3 different steps to solving systems of equations by graphing, okay? The other ones were like complicated steps with substitution and elimination. Today we're just doing graphing. So you have 3 steps, okay? The first step, you need to rewrite the equations in slope-intercept form, okay? So and y equals mx plus b, okay? Today, you don't have to do the first step because you have Desmos, okay? Desmos will do the graphing for you even if it's not in y equals, okay? So we can skip the first step. Second step is to graph the line, okay? When I say graph the line, what do you think I mean? When I say graph the line, what do you think I mean? How about put it in Desmos? Just put it in Desmos, guys. All right, 3. The last step. All you got to do is find the solution. Okay? Find the solution or solutions. Okay? If it's infinite, you're going to have many solutions. Okay? So, now that we all have our notes written down, let's go to problem 1. Okay? I'm going to go ahead and pause the video right here. Try number 1 on your own. Do it. Okay, so in Desmos, we're going to go to Desmos, which I don't have open. It's right here. Okay? Desmos, we're going to type in the first equation. What is it? Okay. And what's the second one? Okay. So then you go and you look for where your intersection is. Where's your intersection? 3 and -5. It's right here. Okay. So what you're going to do is you're going to go to your paper and you're going to write what? Parentheses 3, -5 in the box. Okay. You're going to do that for every single one of them. Let's go on to number 4. Right. Okay. So number 4, when you graph number 4, let's see what it looks like. Everybody do it with me. Okay? So we're graphing x plus 2y equals 4. Okay? And then in the second box, we're going to graph y equals -1/2, 1 divided by 2, x plus 2. Okay? What happens? Why do you only have one line? Right. So if you look at it, you can take off one and put it back on, and you see how the colors change from red to green? Look, even the computer knew it was Christmas. Okay? So, when that happens, what are your solutions? What should your solution be from your notes up here? Right? They're the same line, so they're going to have infinite solutions. So right here, you're going to put infinite solutions. Okay? Let's skip to number 6. Okay? Number 6, we're going to go back to Desmos, and we're going to see what kind of solution we get. No? No? Number 6, y equals, right? Y equals x, what is it, plus 5? Okay? And in the second box, we have x minus y equals 2. Okay? What happens to my lines? They're parallel, right? So if they're parallel, what kind of solution can I have? No solution. Look, if they're parallel lines and they look like this, their solution is going to be no solution, okay? So I'm going to write no solution. It's like a little circle with a line through it, okay? That's no solution. All right? Okay, moving on. I'm going to show you guys how to do the back, and then if you have questions, I'll help you, okay? So, flip over to the back real quick. Flip over to the back. Okay? On the back, you guys are going to be graphing systems, okay? But all you're going to have to do is graph it in Desmos, okay? So, each of your UFOs on the back is numbered 1 through 10. And then down here, you have different equations, different systems of equations, okay? So I'm going to show you how to do the first one, and then y'all are on your own, okay? So, first one, go to Desmos. Type in, what? X plus 6, okay? And then down here, y equals negative x minus 4. Okay? And then you go and you look for where they cross. Okay? They cross at negative 5, 1. Okay? So, hold on. Write down where they cross at negative 5, 1. Okay? And then go find which UFO is at the intersection. Okay? So, negative 5 and 1 is right here. So, they cross at 6. Okay? So, for your UFO, it's going to be number 6. Okay? Everybody understand? All right. Let's go.